All right, let's talk about the real number zeros of polynomials. So first we have the factor theorem. If C is a zero of a polynomial, C is a zero of a polynomial, and this two-sided arrow is a math symbol for if and only if. That symbol means that the first statement being true implies the second statement is true, and the converse, the second statement being true implies that the first statement is true. So if you plug in a number and it makes the polynomial equal to 0, then x minus c is a factor of that polynomial. Conversely, if x minus c is a factor, then if you plug in c, the polynomial will be equal to 0. This is probably easier to understand if we look at a particular example. So here's a polynomial in factored form. So if x minus 3 is a factor, then when we plug in 3, the polynomial will be equal to 0. So that makes 3 a 0. X minus 5 is a factor, means that if we plug in 5, it makes the polynomial equal to 0. Conversely, if you plug in 5 and it makes the polynomial equal to 0, then x minus 5 is a factor. All right, the next theorem is called the rational zeros theorem. If a polynomial has intercoefficients that are not equal to 0, then every rational zero, so this means all of your roots, this helps you find your factors, can be in the form of p over q. So p is a factor of the last term, q is a factor of the first term, and we're talking about every possible factor. So it can be kind of a long list. Let's look at an example. So the possible rational zeros of 15x cubed plus x plus 6 are, so basically we have to list the possible factors of the last term divided by each of the possible factors of the first term. So 6 goes into 6. What goes into 15? 1, 3, 5, and 15. So all 8 of these are possible rational zeros. And then 3 goes into 6. So we have to divide 3 by every possible factor that goes into 15. So that's another 8 because it's plus or minus. 2 goes into 6. So it's 2 over 1 over 3 over 5 over 15. So it's another 8. And then 1 goes into it. So there's another 8. 8 and 8 and 8 and 8. That's a lot of possible factors. So you may be wondering, is there any way to eliminate some of these factors? All right, well, one way to know the number of zeros of a polynomial is using Descartes' rule of signs. You may remember Descartes from the first chapter. He's the guy who came up with the Cartesian coordinate system and named it after himself. All right, so if P is a polynomial with real coefficients, the number of positive real zeros is either equal to the number of variations in sign or less than that by an even whole number. And then the number of negative real zeros is either equal to the number of sign variations in P of minus x or less that by an even whole number. Let's look at an example. So we look at our polynomial and we say, how many times does the sign change? So it only changes once. That means it has one positive zero. Then you plug in negative x, and how many times does the sign change? Well, it changes here, here and here, so it changes sign 3 times. So there are either 3 negative zeros or 1 negative 0. So the total number of zeros in total is either 2, 1 positive, 1 negative, or 4, 1 positive, 3 negative. All right, that might seem a little overwhelming. Let's do some examples and we'll see that it's not that bad. All right, so can you find the zeros of this polynomial, x cubed minus 4x squared plus 3? And if you're already feeling ready, I would hit the pause button and try it. All right, so first let's use the rational zeros theorem, and let's list our possible rational zeros. So remember, it's either plus or minus, and we take the factors of the last term and divide it by the factors of the coefficient of the first term. So it's 3 over 1 or 1 over 1. So there's only 4 possibilities, plus or minus 3 or plus or minus 1. How will we find out if they're a rational zero? Well, we can use division. Let's use synthetic division. All right, so let's just try 3, which would mean that x minus 3 is a possible factor. Remember, we bring down the 1. 3 times 1 is 3. Negative 4 plus 3 is negative 1. 3 times negative 1 is negative 3. 0 and negative 3 makes negative 3. 3 times negative 3 is negative 9. 3 and negative 9 make negative 6. So this is your remainder. If your remainder is 0, then it's a factor, but the remainder is not equal to 0. So x minus 3 is not a factor. Let me write that down. So x minus 3 is not a factor because the remainder is not 0. Let's try 1. Remember, we bring down the 1. 1 times 1 is 1. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. 0 plus negative 3 is negative 3. 1 times negative 3 is negative 3. 3 and negative 3 make 0. So the remainder is 0. That means that x minus 1 is a factor. Let me write that down. That means that x cubed minus 4x squared plus 3 is, so we divided x cubed by x, so we get x squared minus 3x minus 3 times x minus 1. And then this does not factor, so we call that prime. So this is the completely factored form. All right, let's try this problem. Find the zeros of x cubed minus 4x squared plus x plus 6. And if I were you, I would hit pause and try this one on your own. And first, write your possible rational zeros. So we take all the possible factors of 6 and divide them by all the possible factors of 1. So it's going to be 6 over 1, 3 over 1, 2 over 1, or 1 over 1. Now, another way to test for zeros is using the zero factor theorem. So suppose we wanted to test whether x minus 1 was a factor. Well, if x minus 1 is a factor, then p of 1 will be equal to 0. Or I'm sorry, f of 1. Let me fix that. So f of 1 is 1 cubed minus 4 times 1 squared plus 1 plus 6. So f of 1 is equal to 4. Therefore, x minus 1 is not a factor. So we tried 1. Let's try negative 1, which would mean that x plus 1 is a factor. So we just evaluate our function at negative 1. And it turns out that f of negative 1 is equal to 0. So x plus 1 is a factor. All right, so we know that x plus 1 is a factor, so then we can use synthetic division. To divide it out. So what goes here, if x plus 1 is a factor, that's right, this would be negative 1. We bring down the 1. Negative 1 times 1 is negative 1. Negative 4 and negative 1 make negative 5. Negative 1 times negative 5 makes positive 5. 1 plus 5 is 6. Negative 1 times 6 is negative 6. Negative 6 and 6 make 0. This is the expected result because we already know that x plus 1 is a factor, but now we know the coefficients of the rest. So we know that x cubed minus 4x squared plus x plus 6 is x plus 1 times, so we divided x cubed by x plus 1, so this is x squared. And this we can just factor in our head. So we have x plus 1 times x minus 2 times x minus 3. All right, you should be ready to tackle this problem on your own. So first, find the possible rational zeros, and then it's going to be guess and check to try a few. So hit pause and try that one on your own. So to find the possible rational zeros, you divide the factors of our last term, 12, by the factors of your first term, 1. Remember, it's plus or minus. So 12 over 1, 6 over 1, 4 over 1, 3 over 1, 2 over 1, or 1 over 1. Remember, they could be plus or minus. So we have 12 possible zeros. So let's use the factor theorem to test some of them. Let's try plugging in 1. Well, it turns out that f of 1 is equal to negative 12. So x minus 1 is not a factor. Let's try f of negative 1. Turns out that f of negative 1 is negative 6. So x plus 1 is not a factor. Let's try f of 2. And it turns out that f of 2 is equal to 0. So x minus 2 is a factor. So now we can use division to simplify our expression. We can use synthetic division. We're dividing by x minus 2, so this is going to be positive 2. Let's check and make sure there aren't any missing terms. And then we can just write the coefficients of the polynomial down. Bring down the 1, 2 times 1, 2, 3 and 2 make 5. 2 times 5 is 10. Negative 4 and 10 makes 6. 2 times 6 is 12. Negative 12 and 12 is 0. This is the expected result because we know that x minus 2 is a factor. That's why we got a remainder of 0. So my original polynomial is equal to x minus 2. And we divided a third degree polynomial by a binomial, so we get a second degree. And then we can factor this in our head. Wait, wrote down the numbers. Sorry about that. So x squared plus 5x plus 6. We can factor in our head. Which is x plus 2 times x plus 3.